All right, let's look at problem 4 here. If you were to start expanding it out, it wouldn't especially be necessary for the problem, but putting 25 in for n would give you 2 plus 3 times 25. Putting 26 in would give you 2 plus 3 times 26. And so pretty quickly, I think you could pick up on the fact that like we basically just keep adding one more 3 each time. So the sucker's arithmetic with a common difference of 3. So in that case, you could use the sum formula for it. You need to figure out how many terms there are. So if n started at 1 instead of 25, there would have been 125 terms. But since it started at 25, that means you missed out on the first 24 terms. So that means there would be 101 terms divided into 2, so you could get pairs. And then each pair would add up to the value of your first term, which would be 2 plus 3 times 25, which I guess would be 77. Plus the value of your last term in the list, which would be the 125th term. And so that would be whatever 2 plus 3 times 125 is. I guess I'll go ahead and take another step to simplify that. So we'd have 101 over 2, and then times 77 plus 2 plus 375. All right, probably the hardest part in this problem would just be adding that all up. Let's see, 377 when you hug the 2 in. If you add another 7, what is that? 384, and then plus another 7 would be 454, I think. Like so. And then I personally would cancel with the 2 and the number that we have in here. So 101 times, divide the 2 in, so it would be 227. And then 101 times 227, I personally would think of that as 100 227s, which would be 22700 plus 1 more 227. So your final answer would be 22927. There we go. Okay. And is that what I got earlier today? I did this problem? I have no idea. Okay. Yeah, I think so. Okay. Hope I didn't mess that up. I'm sure I'll hear all about it if I did. Okay, let's see. How should the points go? So 5 points altogether. Let's give you most of the points for figuring out to use the correct formula. So 1 point for figuring out that you had 101 terms. 1 point for knowing that you had to divide by 2. 1 point for getting 77 for the first term in your formula, and 1 point for getting basically 377 for your last term. Okay, so that's 4 points, and then the 5th point would just be for getting the final answer right. So there's your 5 points. Okay, problem 5, simplifying this. So let's expand 25 factorial as 25 times 24 factorial, since we've got 24 factorial on the bottom. And then n minus 2 factorial, we'll just leave it that way. On the bottom, you have 24 factorial, and then you have n plus 1 times n, and then the rest would be n minus 2 factorial. Okay, the n minus 2 factorials cancel. You're left with 24 factorial, and then that would equal 25. And then on the bottom, you could write it as n times n plus 1. Oh, I feel like I'm missing something. Sorry. After n, you'd have n minus 1, wouldn't you? And then n minus 2 factorial would be the rest. There we go. Okay. You could leave your answer like this, so I'll just box it because that's a perfectly good answer. And then on the bottom, you've got 25, and then you could, if you multiplied it out, n squared minus 1 here, and then multiplying n in, then that's also perfectly fine. Okay, so scoring for this one, 1 point for getting 25 on the top, And then one point in somewhere in your work showing that you'd have n in the bottom, a point for having n plus 1 as a factor of the bottom, and a point for having n minus 1 as a point in the bottom. And that really only adds up to 4, so I guess we'll just make the last point be for a great attitude on that one. So probably should have been a 4-point problem, to be honest with you. Okay, let's see, problem 6, evaluating the sum. So this is, for problem 6, this is a geometric with a common ratio of 1.5. And so if you were to start expanding the terms, you'd see that the terms themselves approach infinity. So if you're adding up infinitely many of them, the answer to this would have been infinity. And so the answer infinity was not one of the options, so we would need to say none of these. Hopefully that makes sense. For problem 7, evaluating the sum, this time your common ratio is -1/2. So your terms themselves would be approaching a value of 0 very quickly. So you could actually get an infinite sum for this one. So this would add up to your first term would be 2 over 1 minus your common ratio. And so that would be 2 over 1.5 or 3/2. And then a little flip and multiply, you'd be left with 2 over 1 times 2/3. And so you'd get 4/3 for the answer to that one. There we go. Multiple choice is, you know, we all have a love-hate relationship with these because they're all or nothing. So you do need to show at least a little support work. Like here for number 6, the minimalist approach would be to just say equals infinity. That could kind of count as something. And then problem 7, this is pretty typical of what you would need to show for that. So you'll have to have some work to qualify to get credit, but there's no partial credit. I know it's horrible, but that's how it goes.